Hello everyone, I am Dr. Abdul Rasool, your instructor for Geospatial AI Deep Learning for Satellite Imagery. I am thrilled to welcome you to this exciting journey where we will explore how artificial intelligence, particularly deep learning, can unlock powerful insights from satellite imagery. With a background in remote sensing and programming, I'm here to guide you through mastering cutting edge techniques to analyze Earth's data. Whether you are a data scientist, GIS professional, or simply curious about AI and geospatial technology, this course is designed to equip you with the practical hands-on skills. Why this course matters? Satellite imagery is transforming how we can understand our planet, from monitoring climate change to optimizing agriculture and urban planning. By combining geospatial data with deep learning, we can automate and enhance tasks like crop health analysis, weather prediction, and land use classification. In this course, you'll learn how to harness tools like Python, TensorFlow, PyTorch, and Google Colab to build AI models that process and analyze satellite imagery at scale. By the end, you will have the skills to tackle real-world geospatial challenges with confidence. This course is for anyone interested in AI, geospatial analysis, or remote sensing. No prior experience with satellite imagery is required, but familiarity with the Python and basic machine learning concepts will be helpful. Don't worry, we will cover everything step by step. Course objectives. Here is what we will achieve by the end of this course. First, understanding geospatial AI. Learn the fundamentals of geospatial analysis and how AI, particularly deep learning, is applied to satellite imagery. Second, set up your environment. Master the setup of GPU-based systems and cloud platforms like Google Colab for efficient AI workflows. Third, process satellite imagery. Gain hands-on experience pre-processing real-world datasets, including Sentinel-2 imagery, using Python and Google Earth Engine. Fourth, build and train AI models. Design convolutional neural networks, CNNs, for tasks like crop health classification and plant counting. Fifth, apply advanced techniques. Explore cutting-edge applications like global weather emulation and biomass prediction validation. Finally, evaluate and optimize models. Learn to assess model performance and fine-tuning hyperparameters for better results. How to succeed in this course? To get the most out of this course, engage with hands-on activities. Follow along with a coding exercise in Python Jupyter Notebook and Google Colab. Practice is key. Complete quizzes. These will reinforce your understanding and help you gauge your progress. Ask questions. Use the Q&A course session or reach out if you are stuck. I am here to help. Stay curious. Experiment with the tools and datasets we provide, like Sentinel-2 Imagery and Google Earth Engine. You will need a computer with internet access and a free Google account for Colab. Also, software we use, like Python and Google Colab, is free and open source. If you are new to Python, don't worry, our early lectures will guide you. Let's get started. I am so excited to embark on this geospatial AI adventure with you. By the end of this course, you will have built and deployed AI models that can analyze satellite imagery for real world impact. Let's dive in with the lecture two, where we will explore the foundations of geospatial analysis. See you there.